I hope the screen is visible and audible as well. Is my screen visible?
Yes.
Audible? Yeah. Okay, fine. Okay, fine. Thank you. So, like I was just explaining, in the we have seen a few things in the subject. Initially, we were trying to understand the disasters from numbers. From numbers perspective, in the sense, just to give why the subject is relevant and what is the frequency of disasters that hits across the globe, particularly with a focus on Indian subcontinent. Okay, and in the second unit we were discussing about floods and causes and so on and so forth. As per your syllabus, the third unit is on earthquake. We will look into the different components of earthquake and how do we understand this, how do we design buildings with respect to earthquake. Okay, that is the intention of this particular unit, and and this is quite a relevant unit also. Relevant topic as well, because no part of the Indian subcontinent is earthquake free. Okay, that meant we should register in our minds that none of the part in the entire country is free from earthquake. Okay, so I think I have said in the somewhere in our discussions that prior to 2015 NBC, okay, we used to have a map where we used to have something called Zone 1 in earthquake. Okay, so Zone 1 is something which is relatively safe, almost nil or nil earthquake, or the intensity of earthquake that is felt in Zone 1 is negligible. That we used to have such zones. In the revised National Building Code, we no longer have this zone. Okay, so that means the Zone 1, which is supposed to be safe, where no earthquake is felt, is no longer available, and it is been taken off. Okay, I'll show you the map later in the slides, where it will start with Zone 2 and Zone 3, Zone 4, and so on and so forth. Okay, that's one thing that we should keep in mind. So which also gives an indication that wherever we design, we should understand that there will be an element of there's some element for consideration under earthquake. Okay, and also from structure perspective. Okay, how loads are calculated. I think we normally discuss about live load and dead load, right? These are the only load that we discuss about. Actually, in addition to that, we should also discuss, I think this should have been, maybe your structure faculty must have been explaining in detail, but just to give you an idea of when we design buildings, what are the things that we should consider in mind. One is, of course, live load and the dead load. Dead load is nothing but the building, weight of the building, weight of the slab, weight of the columns and walls, structures, superstructures, everything where there is nothing, there is no dynamic component in it. Dead load is something which is, that's dead load. Live load is something, let's say, bringing new elements into the building, or the occupants, and so on and so forth. all these things are considered. In addition to that, there are two more components that needs to be considered, and it is there by default. Is one is seismic load, and the other one is wind load. Okay, so both the components are part and parcel of load calculations. Okay, so seismic load is part and parcel of building load calculations as well. Okay, so that also highlights that the relevance of the topic. Okay, as far as the contents are concerned, there are certain things that is put here. We'll be discussing here and there all the points that is listed here, which includes from what are the causes, what are the terminologies used, different types of seismic waves, what is magnitude, intensity, epicenter, so on and so forth. Okay, and also what happens because of the earthquake. Okay, what are the effects of earthquake, and also we'll see how different building respond to this particular load, seismic load, how a building responds to seismic load, and so on and so forth. And primarily what we will do is we will take from NBC. Okay, there is very well documented section on earthquake. How do we calculate load, and also it talks about what are structural elements, what are non-structural elements that impacts a building with reference to earthquake. All that we'll see. We'll also see some case studies later on, and probably in your studies also you will be taking up some case studies and explaining how earthquake is measured and how earthquake can be understood. Okay, so that's the overall view of the content that is there in the that's there in your syllabus. Okay, what we'll do is we will just quickly run through some of the key terminologies that we will come across when we discuss about earthquake. Okay, so that we will not be going into details of what is what, but at least keywords. Okay, keywords like what is epicenter, what is focus, what is hypocenter, and so on and so forth. Okay, so because we are not what do you say, seismic engineers, but still we should know certain keywords that is commonly used and that you will come across when you read scientific papers, so on and so forth. That much information is fair enough for us to proceed further, and we are primarily interested in how this is impacting the building and how do we design buildings. Okay, so this is just an overview of some keywords that we should pick up when we discuss about earthquake. Okay, so what is an earthquake? It says the movement of Earth's crust resulting from release of built up potential energy between two tectonic plates. Okay, and I think we all know from the geography class and in initial school days as well, we have different tectonic plates across the world. Okay, and when there is an collision, or when there is some kind of rupture between the two tectonic plates, okay, that results in release of energy. Okay, that energy is called the earthquake. That energy is called earthquake. Okay, and how do we quantify that, and how do we identify that the earthquake is occurring in a specific location is all what we are trying to understand now. Okay, so in summary, what is an earthquake? Earthquake is nothing but an energy that is released because of the collision or rupture of two tectonic plates. Okay, let's say if this is one tectonic plate, this is the other one, and always there is a constant rift between the two plates, and when there is significant or noticeable rift or movement that results in release of energy, that's called earthquake. Okay, and there are few keywords used. For example, let's say focus or hypocenter, which is nothing but a spot underground where the rock begins to break, point at which the damage occurs. For example, let's say normally we refer, okay, earthquake occurred 6 kilometers from so and so. If you read newspaper clippings or there's an announcement, what they say is the epicenter was located 5 kilometers from Chennai or something like that. Okay, so what do? We give a spatial reference to the epicenter of earthquake. So what is an epicenter? Actually, if there is a collision between two tectonic plates, okay, and there is some disruption underneath the earth, okay, where two tectonic plates meet, and that location is called focus or hypocenter, and the exact perpendicular point on the surface of the earth above the focus is called epicenter. Okay, so the point on the land surface directly above the focus is called epicenter. Actually, the damage occurs in the somewhere under the earth. Okay, but we give a spatial reference on the surface, and we say that the earthquake has occurred 6 kilometers or 10 kilometers away from such and such in place. Okay, but actually things happen underneath the earth. Okay, so focus is one thing that we should remember. Epicenter is nothing but the surface point where earthquake is observed. Yeah, you can see focus, and you can see the intensity is actually represented here on top, which is called epicenter. Okay, so aftershocks, these are some of the words that we will come across. Tremors that occur as rock adjusts over a period of time. Okay, so these are some of the words. For example, tremors is also is commonly used. What is the difference between earthquake and tremors? Is, for example, let's say here we said there is a movement, or there is a rift between one tectonic plate with the other tectonic plate. Okay, and as a result there is a movement. Maybe it's upward movement or downward movement or sideways. It can happen, and that is actually termed as earthquake. And we also feel the earthquake or kind of earthquake after major. Okay, maybe I'm confusing, I guess. Let's say there is a collision between tectonic plate 1 and 2, and as a result there's some release of energy. Okay, and at a given point of time, let's say 9 a.m., we say that we have recorded an earthquake of 5 Richter scale in Vijayawada. Okay, and it's specific to the time. But even after 9 a.m., probably at 10 or 11 or 12, whatever be they, after this major recording of the movement of earth, we feel certain earthquake kind of observation. Okay, so those are actually called tremors. It can happen before earthquake, or it can happen after earthquake as well. Okay, so which means let's say this plate has moved up, and this plate has moved down, and some of the land that is about to settle. Okay, it's a settling of settling of the earth underneath earth surfaces. Okay, and that is called tremors. And earthquake is nothing but the release of energy measured at a specific point of time is termed as earthquake. Seismology is the study of earthquake. Like for example, like we have different studies being done for specific things. So for earthquake as well, there are specific research or specific domain where specific knowledge is learned. So that subject is called seismology. We all know that, and let's not go into in deep on that. Okay, so we said there is a movement of tectonic plates. Okay, so how the movement is observed? Okay, is it the same throughout, or there is a difference? There are different ways in which earthquake occurs. Actually, there is a term called fault. Okay, fault is a region on Earth's surface that is broken into two pieces. For example, let us say here we were discussing the interaction between tectonic plate 1 and tectonic plate 2. Okay, so in a technical terminology, the line between these two plate is called fault line. Okay, so that means this surface is different and this surface is different. Okay, and it can be visibly seen here. This is an actual image. Okay, and this is a graphics just to explain same layer of Earth surface, how it can be, how it can differ. Okay, so the composition of the plate can be same. Okay, however, there is a distinct line between these two plates that is called fault line. And there are three types of movement that is observed theoretically because of the earthquake. There are three ways in which the earth can move. Okay, so the first one is I have put here. Normally I could have put it in the next slide. Anyway, so the first one is normal fault. The hanging wall moves down, and you can check the graphics here. This is called normal fault. This is first type of earth movement. Okay, so because of the earthquake, there can be a movement of the tectonic plates. The first or conventional or commonly observed movement is called normal fault, where there is the land subsides. Okay, the actually land settles down. Okay, land settles down. This is an example. This is supposed to be a normal level, but because of the earthquake, okay, and this land has settled down. Okay, and that is what is written here. So for example, let's say this is layer 1 and the layer 1 has settled down here. This is theoretically how we can understand normal fault, and I have taken from the literature some books where this is actually explained. This is in real case. How do we read this? How do we read this is you can check the lines. Okay, for example, these lines. Okay, these lines are same. Okay, there is a movement of so that means there is a fault line here, and there is a movement, upward movement here and downward movement here. Okay, so this movement is called normal fault. This is and it can happen the reverse way also. Okay, and this is supposed to be a normal level. Okay, ground level, let us say, and because of the earthquake, some part of the land may come up. Okay, it's called reverse fault, where land mass is actually moved up. Okay, and it's no longer in the same plane, and we have a land mass that has come out. Normally we have seen this kind of observation where we have seen many cases that land subsides, and there are instances that that's why there's a terminology used for that. It's called reverse fault. Okay, here again you can see this is from live example. You can see the movement of rock, okay, that has gone up, indicating there's a reverse fault in this. There's a third one. This is also quite common, and probably in the examples, in the case studies, we will see how this is impacting and what is the kind of thing that happens here. The third one, a third type of earth movement which can be which can be observed is lateral movement of earth surface. Okay, strikes and slips, sometimes they call it. So which means, for example, there is a movement, horizontal movement. Okay, it can be this way or it can be that way, and horizontal movement of earth surface itself. For example, this can be a good simple example for explaining what is the movement that has occurred. Okay, so this is supposed to be the same road, but because of the movement of because of the lateral movement, okay, because of the earthquake, you can see that there is a shift in alignment of road. Okay, so this is called lateral movement, and also called strike slips in technical terminology. Okay, so this is all about movement. Okay, so in short, we have something called normal fault, where the land is actually subsides. Okay, we have the second type, which is kind of a reverse one, where land mass is pushed up. Third one is the lateral movement of the earth surface itself. Okay, so these are some of the terminologies with respect to the movement, and with respect to energy released also, there are specific things that can be read. Okay, in sequence, if you see here, we said there's some release, there's some because of the rupture, or because of the collision between plate 1 and plate 2 tectonic plates, there is a release of energy. Okay, and because of the release of energy, there is a movement of earth. Okay, movement is what we discussed. It can be it can be like this, or it can be the reverse of it, or it can be lateral movement of earth surface. Okay, this energy can also be read, the energy can also be observed, how it is reaching the earth surface, what happens to the energy. Okay, so there are two types of energy that is actually defined. Okay, one is called body waves, and the second one is called surface waves. Okay, we will come back to this the different types in some time now. So earthquakes energy is transmitted through earth as a seismic wave. Okay, two types of seismic waves radiate from the focus. So seismic wave is I have synonymously used it as energy. Okay, energy released. Okay, in a most appropriate terminology to be used is seismic waves, right? So the seismic wave or seismic energy that is released from here can also be classified in two ways. One is called the body waves, and the second one is called the surface waves. Okay, what are body waves and surface waves? We'll just quickly see that. Body waves transmit energy through the Earth's interior surfaces. Okay, only within the under the Earth's surface, the energy is transferred. The seismic wave is transferred. Okay, whereas in the surface wave, it is the terminology itself is sufficient for explanation. It transmits energy in at the surface level. Okay, the energy is actually transferred into surface level, and most of the issue we are concerned is at the energy released and at the surface level. Okay, so within the body wave there are two waves. There are two types of things that can be it is categorized. One is called primary wave. Rocks vibrate parallel to one another. Okay, these are called primary waves. So there is a movement of Earth in one dimension. Okay, parallel to it. Compression waves squeezes and stretch. Okay, it can, for example, it can squeeze. Let's say if this is the Earth surface, or this is one of the plates that we are discussing. The movement of energy is it's parallel. Okay, it's not leaving the energy up and down. It is parallel to the Earth's its surface. The energy as a result, it can compress, or it can compress the landmass, or it can expand as well. Okay, this is why it says push and pull effect can be observed in this type of energy. Can travel through any material, solid, liquid and gases, and it travels the fastest. Okay, so that is primary wave within the body waves. The second one is called secondary waves. Rock movement perpendicular to the wave direction. Okay, so initially here we said the movement is only parallel. Okay, here the movement is up and down. Okay, secondary rock where the movement is perpendicular. Side to side movement can travel only through solid and not through water and other things. Travel little more than half a speed of P waves. I think these are more technical. Let's not get into that. Seismic wave that travels along the Earth's surface. Okay, when P and when primary and secondary wave reaches the Earth's surface, they are called the surface waves. Okay, so in surface waves as well. What I'm trying to say is, let's say if there is a movement of as a result of movement of the two plates, the energy is released. Okay, so that energy can still be within the Earth's surface itself. It need not reach. Sometimes it does not reaches the surface of the Earth. Okay, so those energy are actually termed as body waves. Okay, so that can happen. The movement can happen in this direction, or the movement can happen in perpendicular direction as well. When the energy reaches the Earth's surface is termed as the surface waves. That's what we are interested in. They are actually termed as love waves. Rock moves in sideways like a snake. Okay, so it is more like a horizontal displacement of Earth's surface. Relic waves is like a rolling waves. Okay, so it is more like this is in 2D. You can understand this is in plan. Okay, movement is like this. Relic waves in, let's say this is in section. Okay, so there's an up and down movement. Up and down movement. This is kind of a lateral movement. Okay, sideways. So these are the different ways in which the energy that is released from the earthquake is observed in technically. Okay, so we have seen two things. One, first of all, we saw what is an earthquake, and we said because of the earthquake there is a movement of Earth, and there is a release of energy, seismic wave. Okay, synonymously using energy for seismic wave. Okay, there's a release of energy, and how that energy can be understood is primary and secondary and so on. The energy which reaches the surface of the earth is called surface waves. Okay, that's what which predominantly hits the buildings and so on. Movement we have seen. Okay, it can be upward movement, downward movement, or it can be lateral movement of earth masses. Okay, but how do we measure this one? Okay, what is the way the earthquake is studied? What are the instruments used? And what is for example, let's say if we have to say whether the temperature is hot and cold, okay, what do? We have instruments for measuring. For example, thermometer. It gives temperature readings from X numbers to Y numbers, and we say, okay, if the number is more than so and so, it is hot. If it is if the temperature is lesser than so and so, when we say that the temperature is cold. Similarly, we have devices for measuring earthquake. Okay, so seismometer is an instrument that detects seismic wave. We have seismograph, a device that measures the magnitude of earthquake. Okay, this is the device, and this is also a device which helps in measuring the magnitude. Okay, plotting the magnitude. I think when you just do Google seismograph, you will find some graph like this. Okay, so there is a device which plots what is the magnitude of earthquake that is detected. Okay, this is just detection. This is mapping of magnitude. Seismogram is a visual record of arrival time, magnitude of shaking associated with the seismic wave. Okay, this includes the seismograph information and also little more information on when and where it happened, what is the extent of what is the intensity, all that is recorded as well. And there is something called Mercalli's intensity scale, measured by the amount of damage caused. Okay, so we will see this little later. We will in the case studies we will see how this can be related. Probably this is kind of new for many of us. This scale is not commonly discussed. What is commonly discussed is Richter scale. We always say that okay, there is an earthquake today of 5 Richter scale, okay, and 4.5 Richter scale, so on and so forth. Sorry. So Richter scale is nothing but is a logarithmic scale. It measures magnitude based on the amplitude of the waves. Earthquake total energy use of using magnitude scale. We will also look at this in a little detail, not now, probably a little later when we discuss about case studies, and we'll in fact this is required because we have to know what is 4 Richter scale, what is 5 Richter scale, what is the difference between 4 and 5, all that we need to have a discussion. In fact, I have put something for today as well, but we will also discuss in detail when we discuss about case studies. So Richter scale is based on logarithmic scale, meaning that each subsequent number is 10 times more powerful. Okay, this is the underlining thing. 10 times more in amplitude of vibration. This translates into 30 times more energy than the previous one. Okay, so for example, let's say an earthquake of 5 is 10 times greater than earthquake of 4. Okay, so which means on a Richter scale, this is 30 times. It will release 30 times more energy than the lower number. Okay, so very quickly, when we say Richter, we had an Richter scale earthquake of Richter scale 5, when we compare this earthquake with a Richter scale of 4, which means there is a 30% more energy being released in 5 Richter scale than in 4. Okay, so that's what we should keep in mind between the scales. Okay, there are different ways. How do we locate epicenter? How do we calculate focal focus points? We'll not be going into detail, but just to have an understanding on how it is done. Normally, the arrival time is recorded at the station. Okay, time lag between P wave and S wave is recorded. So, which means, like I said, the energy can be studied in two ways. One is the body waves. Okay, so most of the energy is within this. It remains underneath the earth. Okay, whatever the energy that comes out even after settling of energy underneath the earth itself is called surface waves. Okay, so in that that requires a lot of understanding, and that is marked, in fact. Okay, so primary waves is mapped. Is mapped. The timing between the energy that is released and which reaches the earth's surface is mapped. Okay, need 3 stations to determine epicenter. Okay, what is that? I think this is in line with, for example, let us say we have weather stations. I think the other day I was explaining. For example, Vijayawada does not have direct weather station within the city. So what it does is it takes weather information from closest 5 weather stations. Okay, and then it interpolates and it gives an average interpolated value for Vijayawada or for a specific location. Similarly, in order to determine earthquake, where it has occurred, we need to have three simultaneously. 3 instruments are used from different location to confirm where the location is. And maximum depth of focus, shallow focus is earthquake which is less than 70 kilometers. Okay, most of the earthquake is under this. Intermediate earthquake, so where the earthquake occurs, we are talking underneath the earth. Okay, 70 to 300 kilometers. Okay, deep focus, where the earthquake is recorded way below, beyond 300 kilometers of depth. And how does it impact, and how is it related, primarily related to buildings and site planning? I have put this image just to just to give an idea that if we have a hard surfaces like this, okay, let's say hard indigenous rocks, or let's say sedimentary rock, or if the soil is made of alluvial soil and mud and so on. Depending on the surface and depending on how the landmass is made, the amplification or the shaking can vary. Okay, for example, let's say if the surface is hard, okay, if the surface is hard, if the buildings are if the substrata is something like hard indigenous rocks, then the earthquake that is felt is slightly low. Okay, the shaking is low. Or if the earth surface that we are where we are trying to build is let's say made of sedimentary rock, okay, then there is a slight increase of shaking. Okay, and if in case of alluvial soil there is a huge movement of larger movement can be felt, and in case of other types of soils, muds and so on and so forth, huge amplification can be measured and identified. So how is it relevant? We should know, for example, let's say that's why we do soil testing. Soil testing can be done for two things. One, of course, we primarily do to check what kind of piers can be done, what kind of footings can be done. Okay. In addition to that, it can also give an idea that how strong is our substrata. Okay. What kind of earthquake measures need to be incorporated in the building design or site planning and so on and so forth. Okay, so this is also relevant, and that's why the subject has been put here. Okay, and we were discussing most of the earthquake occurs in the Pacific region. Okay, and of that 80% is shallow. So which means, what is shallow? The earthquake is observed within 70 kilometers of the surface of the earth. Okay, and most of the earthquakes occur along the plate boundaries. In with respect to Indian condition, I said in the beginning also, when we discussed about India as its location and its and the relevance of disaster. Himalayan region or the belt is one of the region where number of earthquakes is continuously recorded and observed. Okay, so this is very briefly on how do we quantify and what are the instruments used for quantification, and how different soil will have an impact on how the earthquake is felt. Okay, now how is it impacting the buildings and the city and so on and so forth? So effect of earthquake can be discussed in different ways. It's not only about the damage of the building. It's not only about the collapse of buildings, so on and so forth. It can have, in addition to that, we'll have a lot of other problems that can be associated with the earthquake. Okay, so I've just put those things here. One is called ground displacement. This is lateral or vertical movement. Okay, there's a lateral movement. I think in one of the images I showed. Let's say this is the let's say access road, and because of the movement, maybe there is a shift in the landmass. Okay, so it can be ground displacement, landslides. Okay, so landslides can happen as a result, and probably we'll have washout. This surface may engulf or may take away whatever that is there in the park. Liquefaction, I think we had discussed in the flooding case as well. Conversion of formally stable ground into a kind of a fluid mass. So these are some examples. For example, you can see here the building has toppled. Okay, here the building has is about to fall, or the land the foundation has gave away. Okay, this particular building, and that is because the soil bearing capacity of that particular soil is no longer is no longer taking the load which is supposed to take. Okay, so this can happen because of liquefaction. Okay, so I have explained before also, but this is one of the important concepts that we should keep in mind. Conversion of formally stable fine grained materials to a fluid mass. Okay, there can be seisures, the back and forth movement of water in a semi or closed water body and so on and so forth, which could lead to flooding. And probably you must have seen a lot of videos circling around during earthquake or during tsunamis and all. there will be a movement of water. For example, let's say swimming pool is there, okay, and let's say if we are shaking or if we are laterally moving the earth, okay, what will happen? By naturally we will move. This will lead to movement of back and forth movement of water as well. Okay, so let's say given take that in a larger context. Okay, let's say in the form of lake or some urban water bodies. If this phenomenon occurs, this could result in, again, because of the movement, there will be a lot of energy getting formed and water may come out. Okay, so because of the movement of earth, okay, we can experience flooding as well. Tsunamis, of course, okay, and this is one of the common understanding that we had developed recently. Let's say recently, maybe post 2005, how large waves can reach the Earth's surface, and what is the reason for having such a large waves, which are called tsunamis, right? Again, this is because of the movement of the earth mass under the ocean, and that results in release of energy, okay, that ultimately is affecting the movement of water, and the water reaches to the seashore. We can also experience fire, okay, because this is again there can be accidents, there can be many things, right? So effects of earthquake is not restricted only to the buildings. Okay, this can have complicated multiple effects. Okay, so this is what is being highlighted here. Okay, so how do we address the issue of earthquake? We'll be discussing this in detail. Okay, but I am just put this here in a brief to give an overview of what are the ways in which this can be addressed. Okay, in last time also, urban floods or floods in general, we saw what are the things that can be done at a regional level, city level, neighborhood level, building level, so on and so forth. So similarly, earthquake can be addressed in different ways. There are certain ways which has been adapted. We will discuss all that. Just to give an overview of how it is addressed, one is having earthquake zones. Okay, for example, let's say the entire country is divided into different zones, saying this is zone 1, zone 2, zone 2, zone 3, zone 4, and which indicates that we have to adapt certain strategies. If we are building something in zone 2, we have to adapt a much strict regulations and design concepts when it comes to zone 3 and zone 4 and zone 5, so on and so forth. Okay, so having an earthquake zone is also one way of one of the ways of coping with the earthquake. Okay, so that means we try to prepare we try to prepare specific mitigations based on earthquake zones. Okay, and plate boundaries. This is another is probably you can say a regional level identification of plate boundaries and respecting that, and then designing accordingly. Assessing local seismic history and future risk. Okay, this is another important steps. So how do we arrive at zones? Okay, for example, how India is divided into different zones. What is the logic? How do we arrive at these zones? So this is actually based on various factors. One of the factor is the seismic history. Okay, how many times we have the recorded earthquake that is observed in this particular zone. Okay, that is also required, and that is also used as one of the coping strategy. Land use planning, we have discussed this when we discussed about flooding as well. So this helps in this land use planning is actually kind of what is it? Non-structural measures, non-structural measures for mitigation of floods, mitigation of earthquake, mitigation of cyclones, and so on and so forth. Heat, you name anything, okay, all that can be brought under land use planning, and accordingly things can be minimized. The impact of the damage impact can be minimized. Okay, that's one thing. How do we further cope up with the earthquake? Coming out with specific interventions in the building. Okay, this is what we are actually interested in, and I have put some slides specifically on buildings, what kind of interventions are integrated, and specifically what NBC talks about, how NBC talks about building or designing buildings for earthquake. Okay, we will discuss this in detail later on. Short term and long term forecast. Okay, this is also one thing. How is it related to coping strategies for any disaster? Okay, and there is a timeline. Okay, every 5 years there will be an impact. Every 10 years there is a cycle of impact. Every 15 years there is a cycle of impact. Okay, and also there is a, maybe I don't know, is it how do we say that? There is an expected earthquake in the Himalayan zone. Okay, you can just Google or you can just look for some materials on the earthquake forecasting. Okay, long-term forecasting, and I'm not recollecting a documentary. There's a documentary on this as well, on the earthquake and Himalayan in the Himalayan range. Okay, and there's an anticipated earthquake. Okay, and that too soon, probably soon, and an anticipated earthquake of 8 and above is kind of forecasted for Himalayan region. Okay, and this is not a pessimistic way of looking at the problem. This is also one way of coping with the earthquake. Okay, because there is a trend in nature. There is a trend, right? For example, let's say every day we have sunrise and sunset. Every year there is the annual solar pattern, sun movement is same. Okay, and there's a natural event that occurs in a very periodic manner. Okay, and these are also some kind of a periodic event. Okay, that has been recorded from historically, and using that there is an anticipated earthquake in the Himalayan belt, and that too very severe. 8 is not a small number. Okay, very devastating number is actually anticipated. Okay, so that is forecasting. Forecasting is also one way of coping with the earthquake. Contingency plan. Okay, let's say we have forecasted, or we are a little pessimistic in our approach, but still this helps. Okay, how do we plan in case of there's an event, disastrous event? Okay, that plan is required. That is also considered under coping strategy. Okay, so I think with this I will stop here. We will discuss about the earthquakes in India, and we will go into the details of how how this map is prepared. I'll show you the map, how this map is prepared. Okay, and how this zone 2, zone 3 are arrived. What are the these are primarily based on building physics. Okay, how building works, how building is constructed, how the materials are used, what kind of structures are being done. Okay, using this map is prepared. Okay, so maybe I'll take this in the next class. We will discuss from here on what is earthquake with reference to Indian subcontinent, and so on and so forth. Okay, I'll just stop here.